Alright.
Told the only person who'd hear me, but she said the thought was making her sick. Sarah doesn't hate the person within me, but I'm not being a good Catholic. She thought she'd get the perfect boyfriend. Look at how I'm proving her wrong. I don't ever doubt she remembers.
Right now I went.
I don't wanna be stuck in your passenger seat. Just let me out, gotta cry a while, and I can't tell you why.
That's stream prep, hold on. Alright. That's enough. Wait. Alright, cut the music. So, what did I do since before and now? So, I can show you. This thing, parser plus LIR plus HIR. This is stream 13, so I give up. I revive the HIR. I essentially try and merge the code bases together. So I just move all these things to old. Alright. Here, so parsing HIR and dumping symbols. So basically, I'm at feature parity with the old HIR parser. Yeah, and that's right. Yeah, and then here, change mut syntax, function decls, unify IR descriptions, descriptors, and impl globals. Alright, so I'll go over them one by one. So I did change the mut syntax. Why? Because it looks better. Yeah, let me get Twitch open. Alright. Yeah, so here's the old stuff, and okay, I changed more than the mut syntax, but just ignore the new function declarations. Let's just take a function that goes add self, right? This does nothing because it has no side effects. But you can do this. XS equals XS plus X1. So how it was before is you'd have the tack at the front. Now you have the tack at the end. And I really prefer having it at the end. I mean, there's for a couple of reasons. Postfix await, postfix deref, right? I don't want to go like seek here to the front and go XS. I mean, my brain works variable and then mutability. So that's the way I do it. So XS tack. And the reason why it looks better that way is because you can have a global variable like this. Global equals something, right? But what if you want to make it mutable? It has it at the front. I mean, if you have a ton of globals like this, if you have a ton of globals like this, I mean, now that's off center. I mean, that just looks weird. So that's easier. Looks way easier. So I prefer it that way. All right. Yes, you have the tack at the front. Looks better. nicer, and so on. All right, and I also made a couple changes here. So change mut syntax function decl. So this is mut syntax done. Okay, so it's got postfix tac. All right, and then here's functions now. Now take a look at this function. Add a I32 b I32 equals a plus b. Now, this is similar to CPP front. Where's CPP front? Editing. CPP front. By Herb Sutter. Is his name Herb Sutter? I watch this guy's talks. Like when he does them at CPPCon. He makes great stuff, but the syntax I really quite like. So he uses syntax like this, but he uses syntax like this, and since there's no tuples in CPP front or C++ for that matter, there's no fancy syntactic tuples like this. I can't use the syntax because what if it's just global tuple and you just have that, right? And then you think, okay, well, it's supposed to be a function. No, it's not supposed to be a function. So I couldn't go that route. But what I could do is I could remove that. Easy. And now you can unify functions and global declarations. So just go to global, goes this, and then you can type it, I32, and then make it immutable. Make it mutable. Yeah, so functions are like this now. Add a, b equals a plus b. Much nicer. Is much nicer. There's multiple reasons why I did it that way, and you can also do that. You can type them explicitly. Yeah, I had a talk. I talked to CI here, and I was like, yeah. So I was talking about whitespace dependent things in this programming language. So since it takes functional syntax called expressions, there are kind of needed to represent them below. So call f with array literal, index f with x. So those are two different things that the only difference is a whitespace. And then here, call f with, wait, hold on, did I? Yeah, okay, so yeah, and then this one, call f with negative x, so unary negation. And then f space minus space x is subtract x from f. And I talk about how in functional languages that use this kind of space separated functions like calling, you lose out on things, right? So you lose out on unary negation, defining array literals and indexing. You lose out on that. And I talk about here. So Haskell. Unary negation only works in parens like this, and everywhere else it's an infix f minus x. So I talk about ways to solve this in existing languages without whitespace. And what our camel does is unary negation is just a completely separate operator. Completely separate operator. So, anyway, so I say this. I was planning to create a different function syntax like this. Add a, b equals a plus b, which won't conflict with add space parens call expression. I'm planning to implement it, but I just want to know what people think of it. Yeah, so this is my rationale. Since this is a systems language, there will be more functions that do one thing rather than take advantage of pattern match syntax on functions. I'd rather make function declarations as simple as possible to reduce friction there. That's the most important. See, when I write in C and everything, I don't usually wrap my whole function in if statements. I write a couple guard clauses at the top, but that's few and far between compared to just taking in arguments and forming operations on them. So you don't really, and plus there's methods. There's going to be methods in this language, right? And usually no one would want to destructure their the receiver. It's I just want to make things as less friction as possible. Because less friction means easier language to write. So yeah, and I say the reason why I like the f of x syntax. So I could say things like syntax brevity and ease of typing, less wrangling with parens and commas, but I haven't written in a language long enough to really know the difference. So this is me not having much experience in languages like Haskell and OCaml. I mean, I admire them, but I've never written in them, which is pretty funny. It's the same reason why I really like Rust, but there's no way. You'd never catch me writing it. Okay, So yeah, but in general, I really like this kind of syntax. It will make composing functions together much easier, especially when in the compiler I'm calling a lot of functions with a lot of literals. Having to wrap everything in parens makes the code look worse. So when you have these kind of like f of x, it'd act like macros. Let's say you have like HIR dup, and then you have like a HIR HIR.expr. I mean, isn't that nice? And you can just fill it up, and then you know this is being called with that. I mean, that's a great. I really like syntax that way. Anyway, I've talked about it enough. I think I gave my viewpoint. So add a b equals a plus b. Now you're gonna have to make matches separate like that. So you lose I mean that isn't that bad. I'm pretty sure I could add what OCaml does and make this implicit. Make that implicit. I could write that down. I could write that down maybe. And let's see. Let me bring this on this. Bring this over here. Yeah. And syntax. Yeah. Zero init. Fun calls. All right. So yeah, this document is very, very old because I'm talking about TVARs here. So, what am I writing? OCaml implicit. Yeah, so it's kind of like this thing. Wouldn't that be nice, right? Wouldn't that be a nice syntax? Or you could probably just do remove the exclamation mark like this equals match, or you could and then like you'd have to a b something. I mean, yeah, that's how I write notes. So all right, get logged. So parser HIR table, change my syntax, function decls, and unify descriptions and impl globals. So I explained this. I didn't explain globals actually. I didn't explain globals. So to define a global, it's simply just something equals expr, right? And it can be literally anything because we do constant evaluation. So I'm running it here. Yeah. Okay, since it's at the top level, there's no ambiguities. You don't need to put a let at the front. You can just do assign something to that. And it says here, so I'm printing out the symbols. And it says main dot something is HIR, and it equals 2 plus 5. Right? And you can do something like this. Equals something plus 50. And then here, main dot take equals HIR, which is a main dot something plus 50. So that's something you can do. And when there's something forbidden, something like that. Something equals something. Now, this is something I want to. This is what I want to solve this stream. So I'm going to implement topological sorting with so what is it called? This is called reverse. This is called reverse post order graph traversal, and we are doing it's like topological sorting. So I think I talked about this before, where we sort the symbols in a way where if we access a symbol, it doesn't depend on the things before it or after it. We solved a dependency issue. We unwrapped a dependency tree into something more tangible where we can just iterate linearly. So, and that's called a topological sort. Where topological sort fails is with these cycles. So what you'd want to do is you'd want to detect them, and that's what I want to do this stream, detecting them. All of this is just simple algorithm that I can copy. Okay, so that's a global, and then you can make it mutable by doing something like this. You can do that with a tag at the end. So you can see there's a tag, HIR equals 3. You can also type it as well, because I have to do 2. Easy. I didn't display the type, but just It's typed. It's typed. Yeah. And the last thing that I did was unify IR description. So that doesn't really mean much when I explain it to you, but it's pretty simple. So I said here, back in here, LIR plus HIR, we have this thing, the symbol. The symbol is a function. Let's say the symbol can have a function in it, because the symbol can represent a function, and in that function you can have a HIR. Inside that function you can have an LIR, and then you can have some RIR. That's like a assembly or something. I'm not decided yet, but just assume I just have a HIR and an LIR. And then here in a global, you can have a HIR, convert it into LIR, and then when you do const eval, you can turn it into an LIR val. Now, how they're represented now is just a symbol. Symbol and function IR desk, and then HIR LIR. Now, what the IR desk is, so how the HIR and LIR work is that they share. They share essentially. They're implemented not in terms of each other, but they're implemented on shared. They share state. So the one thing that they share now currently in this IR desk underscore T is locals. Well, actually, no. So we store the HIR, LIR, and locals in an IR desk T. And the reason why we put them... Yeah, sorry, I explained it wrong. Let me model it like this. So we have your IR desk T, LIR, HIR. And then in your function, you have desk. And then inside a symbol, I have global, an IR desk. So that's how I'm implementing these things. So these functions will have things like arguments, ... and so on. Like global specific things. So that's how I'm doing it. I'm just passing an IR desk around, and what that means is we can just share all of this logic. So instead of just proc local new, it's just IR local new, and you pass in an IR desk. So that's easy. And you run it, it runs fine. So let's build up a sample program, and we can do this kind of topological sorting. Let's do something we can solve. So obvious cycle equals cycle plus 50, and we'll put 50 at the front. Obvious cycle plus 50. Now, what we can do next is we want to define add. Add is a, yep, no, equals a plus b. Great. Here, you know what? Yeah, we can use this the old function. This is what I use for explaining. So let me just put these in together like this. So inc double is x, which is a u, which is an I32. And this takes in a I32, and returns in I32. All right, and how do we implement that? You know what I could do? I could add pattern matching inside an argument. I could do it like this. I could do like x, y, and then do that. I mean, that's not a dumb idea. I'll probably be butchering it. Okay, well, inc double. So how it's implemented is just like this. Inc double. So we take in a tuple. I32, and then all we do is just do that. We do tuple access. Okay, and then what are we doing now? Ident. So identity function takes in a x, turns into x. All right, and then we have inc, which is just pretty simple. Inc. Yeah. This is our dependency tree. So we have obvious cycle, and then these three things which depend on each other. So inc double depends on inc, ident depends on this. So what you'd eventually want the topological sort to be, you'd want inc first, then ident, and then inc double. So these can be in any order, but you'd want inc to be first. Okay, well, let's do it. Well, let's see what it generates first. All right, so I don't put extra new lines. It'd be nice if I had extra new lines. So I'll go do that right now in the table. Okay, it's all the way up here. Table dump. Where is that table dump? So, oops. Okay, now we got spaces in between them. It's still super long and unreadable, but you can probably tell that it's just main.inc being called with T0. Oh yeah, okay. What this is, T.0.0, is supposed to be that, which are like there's some ambiguities there, but it's supposed to be like that. So we can run it. It's pretty simple. Let's find out where this ordering comes from. So this ordering comes from check reorder. So everything's all gone. It's been deleted. But where it starts is here, C reorder and type. So we can go into main and start calling that. Compiler check. Whoops. Alright, so compiler check is you call C reorder and type, which are good. So, 1. The whole point of this pass is, it's not really a pass, but this is its whole point. 1, it performs sanity checks on the symbol table, so it resolves placeholders. And I'll explain what placeholders are in a bit. 2, identifies cyclic dependencies. And 3, it returns a list of symbols in the order they should be processed. Okay. So first, I'll explain what placeholders are. And to explain, I need to go to the table. So, this is a global symbol, or a hash table. A global symbol, hash table, yeah. The parser will insert eagerly into a global symbol table, returning a reference to a symbol. The symbol's fully qualified name is completely unique. No symbol can have the same fully qualified name. Sometimes there may be conflicting modules with different file system paths. This is just some... If someone did some trickery to just somehow the two symbols had the exact same name due to file system, it'll raise a compile error. So they have to be completely unique. Then here, the symbol table works with a sort of eventual consistency, where references to a symbol will just insert a placeholder, and then later on we fill in the details. After the parsing stage, we go one by one and ensure each symbol isn't a placeholder. And if it is, we raise an error. So, this is how it works. Let's say we have some code here. We have a global that is assigned to something, right? And then we have a read. That just reads from global. Alright, so the parser goes from top to bottom. It hits read, and it says, okay, fine, there's a global symbol. I don't need to do anything about it. And then we start parsing the innards. So it reaches global. There is nothing in the scope. Right, there's nothing in the scope, so this must be a global. And what it does is it just goes like, since we don't have a global in the symbol table, it calls table resolve. So it calls table resolve with main dot global. And what it returns is a rsim, which is a just reference to a symbol. And then let's say we have a table. rsim0 is main dot global. And I'm putting a tag here, which means it's empty. I'll put a star here. Okay, so now we have called table resolve main.global, and it returns as a symbol, and the table is filled with a star. That means this is a placeholder. That means someone has read global, but we've never actually, it's not been defined yet. So when we go table resolve it checks hm getty, which is just checks what's in there. If symbol does not equal -1, just return it. And here it says sim description. Key equals qualified name, and is placeholder equals true, puts it in, and then returns the index that it's in. Now, when you get to here, you'd have a table just like this. You'd have a main.global. And then when we get to here, it'll perform this. Table register. It won't be with 20, but we perform a table register with main.global. Right, and when you call table register, you'd need everything comprising of a symbol, so you just need to store all the proper stuff and type in. So is placeholder is the important part. So when you're at this point of the code, it'll have an entry 0. You'd be returning that. That's an R symbol. That's a reference to an indice in the table. And it will return this main global, and have a star here, which means it's a placeholder. And when you get to here, you'll get to a global. And this global, it says table register main.global, and you call it, right? And it searches. Is there something in the table already? And is it a placeholder? If it is a placeholder, it removes the placeholder status and sets it up, right? So now main.global has, it's a global. It's a global. Good, done. That's how it works. So eventual consistency. It can go down linearly, and it would fill in. It would fill in these certain things. Now, what if you do something like this? Read error, which is doesn't exist. Now, what it would do is it'd do this. Main.doesn't exist. And then when this pass gets to here, it iterates through each symbol. So it iterates through each symbol. It does a topological sort, and it does sanity checks. One of the sanity checks is no placeholders. All right, so it raises an error. This obviously doesn't exist. Done. That's the whole point of this eventual consistency model, which is what I use, and it works well. It's the easiest thing in the world. Hold on. Yeah, okay. Hi, new duck. Welcome to the stream. So, we have our eventual consistency with this symbol tables and stuff. I'm doing well, Alright. So, sanity checks on the table, identify cyclic dependencies, translate systems on the order that should be processed. So, yeah. So let's go implement it. So this whole implementation right here, everything that's commented out. What happened is I didn't know much about topological sorting, so I just asked some AI and said pump out some code for me, or some pseudocode, and I implemented it. Now that I'm looking at it, it's a piece of shit. It's a piece of shit. So I need a different algorithm, and I found one. Written by this guy. I read this guy's stuff all the time. He makes great stuff. So three color depth first search and edge classification. So what we really want is reverse post order. Let me explain what reverse post order is. We can go up here. All right, so here. So post order, pre-order, post order, RPO. So all we really need to care about in graph traversal, all really I need to care about. I don't know much about graph traversal. I know how to do recursion, right? But there's specific things about graph traversal. There's like a couple concepts. One of the concepts is proper traversal. In an ordered way. So there's this thing called reverse post order. It's pretty important, especially when you have when you're in a control flow graph and you're doing compiler optimizations. How it works is essentially like this. So this let me take this image in a new tab. Let me delete this and put this here. Let me zoom into this. Okay, it's really bright. Okay, just forget it. Just forget it. So here, so RPO goes from A, T, C, E, B, D. So it goes from A, T, C, B. Wait. A, T, C, E, B, D. Okay, so I'll explain how it works. So it accesses A, and that's fine. And then it does T and C. And then only then it does B. And then it does E, and then it does D. Essentially, what it means is, I don't think you can. I don't think if you can. I don't think you can see this, but let's just hope you can. A is in its own thing. B is in its own thing. D is in its own thing. E is in its own thing, and D is in its own thing. And what it means is A is dependent on this, B and C is dependent on that, this, and this. Right? I don't think. Let's just hope you can see it. Like, yeah. Okay. It's a bad explanation of reverse post order, but essentially what it means is nodes can depend on each other. I want to reach the nodes. I want to reach the children nodes before the parent. Wait, no. I want to. Right? Yeah. Okay. So, B is the most frontal node. It has predecessors T and C. So what RPO does is it accesses the predecessor. So it goes to A. A has no predecessors. And then B. B has predecessors T and C. So we need to access T and C before we can do B. Okay, and then D has predecessors B and E. So we need to do B and E before we can do D. And that's how reverse post order works. And like I said, if we're doing this symbol-based stuff, we need to do it in a way where there's no dependencies. We need to sort it properly. That was the worst explanation of reverse post order, but essentially, it's just a way we can order symbols. Topological sort and reverse post order, they're the same thing. Now, there's this function. I don't really want to do it. And you can assume that post order is just reverse post order reversed. So we can just take this. So how it works is so 3-color DFS and edge classification. So this is like a graph coloring thing. So while a post order function manages to visit all nodes in the graph with cycles, it doesn't do it in a sensible order and doesn't even detect cycles. So now we'll examine a variation of the DFS algorithm that keeps track of more information during traversal. Helps us analyze cyclic graphs with more insight. Yeah, so 3-color. Yeah, so this is how we're going to do cyclic dependencies. This is where we're going to find things. So, and I think I implemented this before in the IR, and I think you'll be able to see that here. Yeah, C-type block, visit, post order, depth first search. So what it is, I just pass an array, and then when I get to here, I calculate the post order, and then I perform a reverse post order by iterating in reverse. That's essentially how it works. So, and we can do much better with this. So let's do it. Reorder and type. Now, the easiest way to do it is just to Control-C this code, remove its extension, move it up into the old, and then we have two things to look at, because I don't like writing code that has all these comments in it. All right, so how does it work? It has gray, and black. What kind of color? So node not in the dict, white, gray, and black. Okay, so let's just write the color at the top. So inside the symbol, I have it is visited, and the comment says for topological sort, but I'm gonna name it something else. You know, it's a U8, and what is it? Sorts color. Sort color. So sim white. Sim sort white. Gray. Is it gray or gray? It's gray. Sim sort black. Okay, good. So let's go over one by one. Yeah, I need to it's a thing. This would also help me find dead code. But what it would also do is it would not access all the graphs. Okay. through them all. Yeah, DAGs are multiple roots, post order unrooted. Yeah, so I need to do this unrooted. But what this would also do is it would also do dead code. So what I should do here is to do would that also mark dead symbols? I don't know. I don't know. I don't know. But I can change this algorithm. So let's do it. Where's it from? Is this one? Yeah, so how I want to do it is I just want to create this PO post order, and then I want to make a function. This called C reorder. Visit post order. Okay, so how's it work is you have a DFS walk that takes in a node. So that's simple. SymT symbol. What does your compiler itself output? Are you using LLVM or something? Right now, it doesn't output anything except debug. But what I'm planning to do is not use LLVM. Initially, I'm going to have C code generation, but so C code generation is going to be secondary. I'm going to implement WebAssembly and then RISC-V. Yeah, it's important I get C code generation so I can easily bootstrap my compiler, but I will never use LLVM. Oh, nice. You know, I should probably rename this stream. It's supposed to be called something else. This is the old stream. What is this called? Uh symbol table. Symbol table topological sort. So this is the most boring name. Type parsing. Good. Why isn't primary target C second? Yeah, so C is something that I'm going to have regardless because it's the most portable thing in the world. There's nothing more portable than C. So if I want to get my compiler running on everyone's computer, it'd be nice to have a binary that could do that. So visit post order. So color is a dictionary and the order is this. So all it takes in is not an LIR block, but a symbol. SymT post order. Pointer PO. Sim. I'm gonna make this awesome. So sim color. So color equals gray. So it's like symbol sorts gray. So for successors in graph successors. What does that mean? Graph successors. That's after. But let me check what I did before. No, it's just successors. So I just iterate over the terminators. But this is not an IR. This is symbols. So we need to inspect the HIR. So we need to do a HIR walk. So it's just a switch. Sim.kind. It's essentially like this. For dependencies. Okay, sim.kind, and then all these things in here I can type. Okay, so we have a procedure and then type. There's no dependence yet. So no reached. So in the symbol procedure, all we have is like dproc desk HIR. This is our tree. All right. So walk here HIR. Expert. So all it is successors. What do we wait? Successors. What does that mean in the context? I think it means like dependence. Tries to find dependent. Okay. All right. So it tries to find dependence. Sometimes I have like a brain fart. All right. Takes in the HIR now. What's the issue? Why is that not? Nah, it takes in the symbol. So the current symbol, rsim. All right, then we do the same for global. Takes in the dglobal. Good. Walk. Yeah, visit successors. Okay, it's the big switch case now. Which is the most annoying thing, but what can you do? Half of these things kind of symbols anyway. We can order them that way. So let's just order the things that cannot be symbols. So integer literals, bool literals, tuple tuple unit can't be. Separate them like this. Size of type isn't even a thing that I'll be implementing yet. So that can go. But field? No. So field access, no. Voiding, yes. Return, yes. Continue, no. Break, no. Call, yes. Cast, yes. Symbol is what we're looking for. Go at the top. So break, call, cast, local, no. Slice, yes. Index, address of, yes. No. Address of is no, because we're not technically. Because you can do something like this. You can do something like this. Actually, we'll put it in the example. You can have something like intrusive is a pointer to an I32, and you just take a ref to self. I don't want that to be something. But then you'd also have to, you could do something like, so I'd need to go inside as well, but if it's just that, address of intrusive, that's fine. Okay, what else, Array, tuple, lambda I'm not handling yet. Array, tuple, match, do block, loop, if, assignment, infix. Infix? Yeah, postfix, prefix, deref, index, slice, cast, call, break, return, avoiding let. Okay, all right, let's do it. Empty. No, break. All right, let's just check symbol. So. If expert.d sim equals rsim, we mark that as a successor. As a definite successor. Alright, there's a definite successor. Oh, yeah, you wouldn't need to pass rsimpo, would you? No, you would. Alright, visit definite successor, and then what does it do? It checks if it's gray, so you'd want to do this. No. Yeah, first you'd grab a pointer. So, color.get successor. Okay, so we wouldn't need, we'd only need this for errors, so. So, if suck dot sort color equals, no, sim gray, assert not reached, cycle. If suck not in color, just do a switch. Just switch over there, it'll be easier. Looks nicer. So, this is cycle. Actually, no. It looks worse. Alright, I got ahead of myself. If successor not in color, so it has to be white. From a DFS walk. So let's just do that with visit PR. Alright, and then PO with successor. So, hello Lucas, Kirby Rules. Welcome to the stream. Right, if color gets successor equals gray, if successor not in color, do DFS walk. What are you up to? I'm implementing my compiler. I'm doing topological sorting. So all we need to do is order.append. So let's do that now. Push. And I hope they can fill it in for me. Yep. Here, our successor. Awesome. Thank you. Yeah, and then what you'd want to do is color. This is supposed to be in successors. Okay, so all it does is visit successors, and then at the bottom, we do an push of the symbol, and then we do symbol, D sort color. It's black. It's fully sorted. Good. DFS walk root and then return order. So how it would work is you'd call visit post order on the first symbol. It's like how it works. You to call on the root. But what I'm going to do is I'm going to call on every single symbol, going all the way from start to finish. So let's do it like that. You'd also want a sanity check, but I do a sanity check up there. Right? Yeah, okay. So when visiting definitions, ignore placeholders. An actionable symbol. No placeholders. There'll be errors when we visit the dependence. It's the comment above. It doesn't mean. Alright, so if symbol sort color equals sort black. Symbol does not equal sort black, we visit it by doing a C type. We do a block visit. So visit post order. We're gonna visit this in post order. We're doing that. PO and I. And then we run over it reversed, which is pretty simple. Just gonna steal from this. I'm gonna rewrite it. Good. Now let's just print them. So we it's an rsim t. Awesome, and we just print it. Actually, we'll print it with a name. Let's sim kind. We'll do order. So just I. And we get its fully qualified name. So let's do sv from sim dot key. Good. Well, we only test it out now. Actually, no, we can't. We didn't finish this. Well, we can finish it. We're doing this. All right, fill it in. Where arithmetic or pointer type is required. Is that right? D array. That's rare. HIR. Yeah, I don't get it. It's supposed to be LLMs. Actually, no. No, that's okay. So it's the wrong way. It's supposed to be like this. Yep, that's right. Okay, good. Tuple. Do it. Match. No. Do block. Yes. Expert.d. Do block. Expressions. And we're running over those. Alright, all loop is just unary. Expert. Alright, if is the readdress. Perfect. Express sign. You need a LHS. RHS. Infix, same thing. Dinfix. Postfix. That's SRC or expert. Yeah. Prefix. Good. DRF. Great. Don't tell me it's SRC, right? DRF. Yeah. Index. I think that's 2. So it's expert and index. Slice is 3 address, so I think I can fill that in for me. But it's also nullable. Oops. Good. All right, casting. Oh, it's unary. So cool. Good. Decast. Just decast. You'd visit the F and then args. Okay, break. Speed break. Expo. Return. And voiding. The voiding and let's. What would I do? It's just expo. Yeah. Well. Good, simple. Let's run it. That's rare. What is that? Is that a Unicode zero length space? What? No! Is this really what I think it is? Let me just change the theme because this theme sucks. Let me just write this to F. Okay, F. Let's just cat F real quick. Let's do a bat. Do I not have bat installed? Let me just install it. Bats. Right? I think it's batcat, right? I think it's bat. It's bat, right? Bat. All right, and then just bat F A. Oh. Let me do XDD. XXD. Why not even have XXD? Okay, let's XXD. Fine. Tiny XXD. Fine. And then F. What is that? Is that like a zero width space? I don't know. Anyway, Copilot just inserted a Unicode character into my code that isn't recognizable. I think that's like the easiest way to break someone's code. I don't even know what this is. UE00. See, and if I hover over it, I can just click delete. Or it doesn't delete something, right? Is that's still a dot? I don't know. Let's just run it. Numerical LLMs. Yep, tuple. Hi bro, what are you doing? I'm running a compiler. So I'm currently doing topological sort of all my symbols, so I access them in the right order. And avoid cycles. So when I say cycles, I mean cycles. I mean something like this, like obvious cycle 50 equals obvious cycle. Hi system before, welcome. Welcome back. Alright, so we've implemented the access. Actually, before I actually test, let me check because I have some sanity checks here. Visit dependent. So if it's a placeholder, yeah. So impossible to self-recurse into incomplete functions. I ditched OS Dev and have been teaching myself ML for the past 1 to 2 weeks. So You mean ML, like standard ML, or machine learning? You can never tell these days. Machine learning. Okay. Yeah. That's nice. Yeah, I've always wanted to do machine learning, but I feel like that ship sailed. Everyone's just riding off all the last innovation happened in the last 10 years and it's over. So I don't think if I joined I could add much to the field. It'd be nice to learn. It'd be nice to learn. Uh the way I take advantage of AI is that I just use Copilot. I don't even pay for it. Okay, so this simply so visit PO. So you're essentially visiting a symbol right now. Visit successors HIR. The entry point is visit definite successor. So all nodes will go through here. All nodes. And all nodes that aren't invisible. All nodes that aren't no return. Is it not all nodes that aren't all nodes that have reference will go through here. Okay, so just any node that those references in the program, including placeholders. System before says, I think ML will keep progressing as it has for the last couple of decades, even in a more extreme rate. It might take much higher proficiency to make an impact, but it's a challenge we want to take. Like, yeah, yeah. Yeah. In its current state, like people just be like, okay, what if we did a large language model, but we gave it more training data? That's what the state of AI feels like today. But I feel like there's someone's gonna make a breakthrough, and these I mean, and there's more fields than just large language models. But that's where the money is at right now. Uh, you know, um, we're probably just scratching the surface. I mean, there's no way to tell. There's no way to tell. There's no point in me giving my 2 cents. Anyway, all right. So successor. Node has a sim has a referent. Wait, where do I check that? Biggest problem right now is making everything far more efficient and open for basic users. George Hodgson, tinygrad. I heard about that. I read it. It's amazing. I feel like what he's doing, I could apply myself there, because I read it. It's a super simple instruction set that implements all the basic tools needed for machine learning. I mean, I'd love to start there. I'd love to start there. That's something that's actually really interesting to me, because it's with my idea with my things with compilers. Yeah, that's right. That's right. Okay, that's exactly where I want to put my time into. So yeah, I like that's one of the coolest things that I've ever heard of in machine learning. Like tinygrad is great. All right, visit definite successor. So we know sim has a reference, so it's a placeholder. Is it? Do we not have any placeholders? Oh wait, hold on. Hold on. Okay. Sim sort grace, it's a cycle. Let me think for a second. Main, and then test equals main. Okay. Yeah. All right. Sim. Yeah. All placeholders. Placeholders are reference. So error user. Obviously, you'd want to write something like. You'd want to write like. Error with pause. You'd want to take the current successor, which is a placeholder, even if it have its location. And actually, where do placeholders go? Does a location get put on a placeholder? No, a location does not get put on a placeholder. This is what I want to do. So when you create a placeholder, you have to put a lock. So on error, so you can raise an error. Or you can put it on the symbol. Yeah, that's right. That's right. Successor. Do an on error. Yeah, on error. It's the kind of thing I like to do. So, and then let's just raise an error. Oh, we're not placeholder. Undefined ident, unknown ident. S, and then we'll take its short name. Suck. Short name. Okay, and then visit definite successor with a expert dot lock. This is its location. Good. Now what we want to do first is we want to do this. Test equals A, and A is obviously not known, so it'll raise an error, right? No, it didn't. All right, we'll get to that till later. Here. Sim. Okay, successor sort color equals sim sort gray. So it's a cycle. So we want to error with pause. Well, okay. How does VLang do it? So let me just get the compiler real quick. VLang v. I assume I have it. Oh, I do have it. Okay, CDV. We want to just do this, right? Oh, okay, make. Okay, that can wait. Let's just make an error. No, I'm lazy. I'm just gonna copy their errors. I don't wanna write errors. Come on. It's great how all V does is just, I mean, this bootstrap is the easiest thing in the world. You go into V and you just type in make, it compiles a C file. Done. You have your bootstrap, which is what I want compilers, which is what I want compilers to be, easy. So const A equals A. Okay, cycle in. Okay, so you can do cycles in. So you want to do a cycle of itself, right? So you want to do cycle self, do self, then cycle to self. So that's two things. So if suck equals sim, self to self, you want to raise an error like yep, cyclic dependency on s, and then we just do an assert not reached because I want to check cyclic dependency on obvious cycle. Wow. We just did it. That's great. Wow. Can't believe it. Well, I can believe it. But that's great. Cyclic dependency on obvious cycle. Great. When we can refine the error message to make it easier. Or let's do something else. test equals test. Obviously, we'll raise an error on that. Cyclic dependency on test. Now let's do test 0 equals test 1. Test 1 equals test 0. Does it just ignore it? I don't know why it ignores it. I think that's something I should look into. But this is what I should definitely look into. I don't know why. So main.ts, right? Yeah, let's look in track reorder. Does not equal simsort black. Wait. Oh no, it has to be white. Simsort equals white. Okay, I was wrong. Well, it gets it here. Cyclic dependency on obvious cycle. It doesn't get this. It doesn't get that. That's annoying. Right, let me comment this out and let me just see if the order of this works. And let me remove intrusive. All right, so the first one is main.ident. The second one is main.inkdouble, which is That's not right. It's supposed to be ident, ink, and then inkdouble. Yeah, that's weird. That's not supposed to happen. It's annoying. Sim.sort color equals sim.sort white. Yeah, I don't know. I don't know what the issue is. M to C and G to D. G to D. Let me run through the code one by one. I hope this is right. So we recall C reorder and type. Let me go over all the symbols. Symbols are placeholder continue. Will be an error soon. So if sim.sort color equals sim.sort white, you just call it. All right, vvisit.po. Essentially calling DFS walk. DFS walk on entry, node.color equals sim.sort gray. So this is the first color. And for successors, so we just call dependencies slash. Okay. And then for successor and node graph successors, we visit successors all the way down, and then we call where's expert call? Yeah, and then we call visit definite successor. So all symbols that have reference will go through here. All right. If successor is placeholder, that's obviously an error. If successor.sort color equals gray, print cycle. That's not supposed to be here. If successor not in color. Not in color is white, not discovered yet. So if successor.sort color. DFS walk with successor. Okay, so this should work. This should really work. I don't see why it shouldn't. I don't see why it shouldn't. So if successor not in color, do a DFS walk. Other, perform a print with our cyclic dependencies. So we visited all the definite successors, and then you go down to here. So visit successors. Order.append the node, just the rsim, and then node color node that symbol equals black. I mean, that seems right. Seems right. The thing is, you'd need to find a root. I think that's the issue. I think that's an issue. That's what would happen is it would start in the middle of something. Because you'd have like S, 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 and let's say these are all grouped, right? What if it just started in the middle here? That's obviously one of the big issues. We need to find a symbol with no reference. But we can start in the middle of the graph. That's a hard thing. That's something that this doesn't tackle. So I can leave that till after stream. So I've only been streaming for an hour, which means I can do some other things. But I can refine this algorithm while I can. But I think I taught the basics pretty well. Yeah, this seems right. What if I flip the order? Okay, so this doesn't work. Cyclic dependency on test 1 at least does, though. Okay, well. We can commit this, though. This is good so far. We can commit this. Alright. Check reorder. Yep, table, commit. So, what am I going to name it? I'm going to name it... What do I name it? Sorting? Checker. So, checker. Table. Checker. Sort. Color topological sort. Okay. And then what stream is this? Stream 14. And commit. I think that's good. Commit. Good. We can sync that. Okay, now what to do next? What to do next? Now, what I think we should do next is structs. Custom user-defined types. So let's just start drafting out a syntax. So this is how I want structs to look. I want them to look like this. I'm just gonna copy Rust's syntax, NV syntax. So it's a struct foo, fine foo. Done. That's the syntax right there. Sorry. X and Y. Simple. I think that's pretty simple. And then type aliases is that. Okay, well, we can start by doing this. Let's see what it does. Unexpected character tag. Where does that come from? Plex. Okay, so I don't have braces in this language. There's like, it's not even a token, these braces. So let's just go add them. We can go inside def.h. Do them right here. So talk O CBR, open curly braces. Okay, open curly brace. Open curly brace and close curly brace, which is open and close. Good, easy. Now, yeah, unexpected foo, expected equals. Okay, struct isn't even a keyword yet, so let's make struct and type a keyword. So this and this type. We'll make struct first because I like it that way. Actually, yeah, it's like this. Talk struct talk type struct type. All right, now it says unexpected struct, expected top level statement. Okay, now let's go make that top level statement. Well, we can make that really any kind of statement. Let's do this. Where's it? Parser? Yeah. All right, because I want to be able to define structs inside lexical scopes, which with our language, with the special symbols, makes it really easy. All right, so the most important thing is here, p top statement. Guess talk struct. Now, what I want to do is to do so, you'd want to do a p next. You know what, p struct as well. Let's make a function for that. Let's call p struct. P check talk ident, and then we'll get the name and location. Good. It's simple. So how are we gonna parse this? Struct is basically struct 1 2 3 4 a b. Now, where are we right now? Let's say we're right here. Yeah, I like putting these types of comments in. Alright, let's just say we're right here. And then just p next, and then p expect open square open it's open s obr open c what do they call them? Open OCB and talk closed CB. What? That's the stupidest name. Who came up with that? Alright, fine. Talk OCBR. Yeah, and this is what I want the to-dos to be. Yeah. Alright, now we're inside. So I want to do a while e dot token dot kind does not equal talk ccbr. And how does it work? I'm going to copy from this. Expert tuple actually expert array. So let me just take that because I'm lazy. So no commas needed, right? No. All right, simple. So it's essentially just this. Parse this whole thing. So what you want to do is stir. Field lock. Go field. Field lock. Speed type. So now let's go to the type system. So we have dfunction, declosure, declosure union, deslice, derray, detuple, depointer. Now let's add another thing. Struct, destruct. Now, how is this represented? There's no names. It's just fields. Go here. T-info. T-info field. Right, struct field. So it's an I30 name. And we'll store its location as well. No, we won't. No, we won't. What do I, it's just a name and type of field, right? Yeah, it's just name and type. Field type, and then we can type def. T-info SF. Your struct field. Alright, fields. That's in the wrong order. Fields, great. TI, T-info, SF, fields. Equals null. And then let's just push it. That's good. Fields. Alright, and then just push it in. Great. Great. That's the simplest thing in the world. And then all we do is just construct. See you next. So, what we do is just create one. So, return, actually no, so type T. Real type is type info. So, we'd add an entry, struct type. Tuple, function, closure, closure union, pointer, slice array, struct, type struct. Easy. I mean, that's the easiest thing in the world. Pretty simple. What we need to do is register it though. Type table, register. Symbol. We'll create the qualified name, and we'll have a symbol type, and its type is just type. Now, how types essentially as symbols represented is just like little aliases. So yeah, it's just simple type, and if simple type, this is the type. It's pretty easy. Now, we can't actually use this type. Oh yeah, okay, so case symbol type. We need to have to do a special type def, right? Anyway, Okay, now type debug stir isn't implemented. So let's do that for structs. Schema for string. Alright, simple. You can do this for me. No, there's fields. Oh wow, how we? Because for printing a type, it's gonna need. Actually, it should be fine. Be fine. For TI for SF field. What does it look like? Check reorder. Okay. Case symbol type. Do nothing. Do an ePrinter. Doing nothing. I missed something. What? Main.foo equals struct. Main.foo. How weird. I don't know how that happens. Allocate more space. No? Let's find out. How it works is that you'd want to type first. Zero main.foo. I don't get. Oh wait, it's not committing. That's why. Sometimes I forget to write. All right, close the brace. Great. Let's go to main because I want to find out why there's not a new line. Ah. All right, main.foo equals struct x and y. Still need to fix that. A weird spacing. Good. X is I32, Y is I32, and that's main.foo. All right, now let's just try and use this. I'm not gonna create struct initialization syntax, but I will try to use it. So let's say global equals foo equals 0. Like, we're not gonna attempt to parse that. Now, parser expr because we're going to ptype underscore expr. This is one of my assert unreachables. Okay, so to do integrate module system later. So this is later. We have a module system when we have our type symbols. So we can do it like this. how do we do this in ident? So how it works is when we reach here, when we reach a type, it'll be type. But it can also be module dot type, and then you need to find out where the dot is. So let's do it. Check reorder. P-ident. Okay, so if ID equals p import identifier, so let's just copy that. I'll change this to lit. In lock. Speed in lock. Alright, expected dot after import name used here. Alright, to do. Inside p-type, duplicated code inside p-type, and then ident. Yeah, I mean, I don't like this duplicated code, but that's what it has to be. Alright, so now we have a fully qualified name. What else we need is to do sort of a table result qualified name. We get our rsim. Else. We need to search for a okay. So to do perform search of local scope in case. Alright, and then all we do is just do this. Let's do a T. p.mod and literal, so we get a qualified name. We'll get a main dot zero. And type sim table resolve. Great. So now what we'd need to do is we don't want to resolve to a global when that type is referenced. All right, type symbol. Okay, all we need to do is return new type, which is a reference to that symbol. So we have to create a type, which is called type underscore symbol, which is pretty simple. Type symbol or alias. Alias is fine. Or alias. Yeah, type symbol. And it's just D symbol. It's just a RF symbol. Okay. Let's see original def of an R symbol. Should be up here. Great. Now we can create a type symbol. Yep. RSym T symbol. Easy. It's the easiest thing in the world. Now we just return type equals new. D symbol equals epsilon kind equals symbol. Easy. I think that's right. I mean, we need to do p next. Yes, but I think that's right. All right, main.global HIR 0, doing nothing on symbol.type. Okay, let's create a function that takes us in. Take, which is an A, which takes in a foo, equals 0. Let's see it printed. Type debug stir unreachable. Okay. Case type symbol. We need to print. No, that's wrong. Different symbols. Is it mod? That's key. It's a fully qualified name. Okay. Main.take takes in an A, and that's main.foo. That's pretty good. I mean, that's pretty easy. Let's do some like embedding stuff. Struct another. There's a foo inside it. Oh, okay. Compare type info. So okay, we need to do this as well. Type symbol. This is for type and turning. Yep. Case type struct. All right. Ooh. Well, I mean, I did it for me, a copilot. I could do hashing. I mean, to do proper hash cons. This is ugly. Okay, so main.foo is a struct, x and y. Main.another is a struct, x is a main.foo, y is an I32. Easy. Now, this is something, I'll fix this string stream. I'll do the string stream. So there's something we could do. We could do a foo, which refers to a global function. Let's just make a function like f. Takes a nothing, equals 0. Right, well, we'll do a capital F to pretend it's type, and then we can do that. Now let's see what happens. So main.f, and then y is main.f. So there's obviously this this distinction that has to be made in here. What if a type symbol refers to a symbol that isn't a type? So that's a thing that we have to do. That's a thing that we have to watch out for. We have to error for this. This symbol is not a type. So we can do this by going into check reorder and perform another thing. So let's do this. For we have to iterate through the entire type table. Through entire type table for type t. Actually, that's right. No, for. Is it HMNU? Okay, well, that's completely wrong. Type.c. How do I iterate? Yeah, iterate backwards, but I just want to iterate forwards. So, for u32i equals type len. Wow. I'm surprised I have this static. Like, I love globals. Love globals so much. Yeah, this can go right next to all my wonderful globals in the header. There we go. Excellent. Great. All right, now types. Type I equals 0. Make sure I is less than type len I plus plus. Types I. All right, now if info dot kind equals type symbol and again equals type symbol and okay, no, I've got to nest them. It's getting around it. And sim t pointer sim. Well then, sim dot kind. Sim dot kind. Sim dot kind equals no, okay. If single time. Where's an error? Okay, and to do no will cyclic. It's a cyclic. Times. Okay, expected, well, we have to raise an error, right? No, that's not right. We can't do this. We can't do this, yeah. Because we would need to raise an error on the use of function. Okay, but I think that's good enough for now. I think that's great. We did a lot. So table, parser util def or extra. Okay. All right, what did we implement today? Okay, table. Good luck. Those types. Okay, table plus checker. Parser. Struct definitions. Type symbols. What else did we do? And type symbols. That's what we did. Okay. Before I finish, what would be good is duplicating the logic in p ident p type. Actually, you know what? No, I'm done. I'm done. That's it. Actually, oh wait, let me undo the command. Undo, and then we'll do a hash 14. As much as I didn't get much engagement during the stream, that was great though. Usually I'm bogged down with questions. I love answering them. But this will make it easier for me to edit in post, right? Okay, well, I think that's it. I think the stream's over. That was a good stream. I implemented all the stuff I needed. It wasn't even that long. But I think that's it. I think that's it. I'm gonna end the stream in 30 seconds while I quickly do something. All right, it's over. Goodbye, good night. Good night, everyone.